Hello, everyone. Welcome back. Welcome to our very first day of Unit 4, which is our last unit for Grade 12 Advanced Function. So, congratulations on making it this far, and let's get into our last unit. Okay, so first of all, I want to talk about radian measure and what that means exactly. So, whenever we're measuring the, uh, you know, whenever we're measuring an angle, so far we just use degrees, right? We use anywhere from 0 degrees up to 360 degrees, which is the full circle. However, when it comes to the radian measure, we're actually going to use, something a bit different. So let's talk about the discovery of pi actually before we get into radian measure. We know that this is d, the diameter, and we know the circumference is pi times the diameter, meaning that pi is equal to the circumference over the diameter. And the circumference of any circle divided by the diameter is 3.141592 and whatever else. This is to scale for every single circumference over its respective diameter, right? They're proportional to one another in this way, right? So pi is really just circumference over diameter, and that's going to be a never ending decimal. That's approximately 3.141592. I'm not sure after that, but something like that. Okay, let's talk about radian measure. So a radian is a unit measure of different angles, okay? So when it comes to the circumference, again, we know the circumference is pi times the diameter, which is the same as 2 pi r. You may have been taught that circumference is pi d or that circumference is 2 pi r, and either one is the same because we know that 2 times the radius is the diameter because the diameter is just two radiuses together. Okay, so for radian measure, the formula that we need to follow for radians is this one here. Okay, it is that pi over x is equal to 180 over theta, where x is the angle in radians and theta is the angle in degrees. Now, in other words, that means that pi radians is equal to 180 degrees, right? And as such, we know that 2 pi radians would be equal to 360 degrees, and pi over 2 radians is going to be 90 degrees, and so on, right? We know that this is the formula, that pi radians is equal to 180 degrees. And so that's how we can convert. Now let's do some practicing with these conversions. Here it says to find the following angles in radian measure. So how do we do this? Well, we need to say that we have 90 degrees here, and we're going to multiply this by pi over 180 degrees, right? Because as we said before, pi radians is the same thing as 180 degrees. So by multiplying 90 degrees by pi radians over 180, the degrees cancel out, and then we get 90 over 180, which is just 1 over 2. So we get pi over 2 radians as our answer. We can use the same method for 150 degrees. If we have 150 degrees, we're going to multiply this by pi radians over 180 degrees, and that's going to be 15 pi over 18 radians. So there we go. All right, what about 225 degrees to radians? Well, 225 times 1 essentially, right, times pi radians over 180 degrees is equal to, well, let's see, what's 225 divided by 180? Well, that's gonna, if we divide that out, we're gonna get 5 over 4 pi radians. And notice I'm not switching pi for 3.141592 or anything like that. I'm just keeping it as pi. Generally, for radians, we do. We usually keep it in just the exact value. Of course, it's important to know what pi is and to understand where it comes from. Yes, but we can just leave it like that. We don't actually have to swap it. Now we will for these examples, though. Let's move on to finding the following angles in degree measure. So for this first one, we're going to do 3 pi over 2, and then we're going to multiply this by how many radians? Well, we know that 180 degrees is equal to 2 pi radians. So in this case, we know that pi and pi cancel out, right? It's also important to note pi is always the same thing. We can't have like pi 1 or pi 2 or pi 3. No, pi is always just 3.141592, and so on, a never ending decimal. So these can cancel out, therefore. And then we have 180 times 3 divided by 2. So that's 180 times 3 divided by 2, which is 270 degrees. So therefore, 3 pi over 2 radians is 270 degrees. Now what about pi over 4? We're going to multiply that by 180 degrees over pi. I got this wrong. Okay, so next let's talk about how we would figure out these angles in degree measure. So let's go ahead and do that. So for this one here, we're going to have 3 pi over 2 times 180 degrees over pi, right? Because 180 degrees is the same thing as pi radians. So that's going to be equal to 270 degrees because pi and pi cancel, and then we just multiply 3 times 180 divided by 2, and we get 270. Good. For this next one, we're going to say pi over 4 radians times 180 degrees over pi, which is equal to 180 divided by 4. So these cancel out, and that gets us to 45 degrees. All right, and what about this one? 7 pi over 6 times 180 over pi. Well, the pi's cancel, and we just get 7 times 180 divided by 6, which is 210 degrees. And there we have it. Awesome. Okay, now let's talk about arc length. So arc length is the distance around part of a circle related to the size of the angle created by R1 and R2 and the magnitude itself. So here we have R1, and here we have R2, okay? And then here we have our angle theta. And this length here is called the arc length, okay? Right? Because an arc, remember, is part of a circle, right? Not the full circle necessarily, but just part of a circle, right? And so we know in general that it's true that that the circumference is 2 pi r, correct? We know that's the circumference. But what we need to know is we need to know what is the, how many degrees or radians over the full circle do we have, right? Is this a quarter of the total circumference? Is it a third? Is it 2/3? Is it, I mean, it doesn't look like it's 2/3, so we can rule that one out. But you get my point. We need to figure out, what's the measure of this angle so that we know how big this arc is, what percentage or what proportion of the arc, is the arc compared to the total, because we know how to find the total. And so if we can find the degrees, then we can do it. Okay. So let's do this example. It says if a circle has a radius of 45 centimeters, determine the arc length for the following angles. So our arc length is going to be x times our radius is going to be our arc length, right? So in this case, it's going to be 2 pi over 3 times the radius, which is 45. And that's going to be 90 over 3 pi, which is 30 pi. So 30 pi is our answer, which is about 94.2 centimeters. Now, how do we know that? How do we know to do x times r? Well, we know that for the full circumference, it's the full 2 pi, right? The full 2 pi radians, so the full circle times r, right? Because in this case, the angle would be everything. It would be a whole angle. It would be 360 degrees, which is the same as 2 pi, right? And then times the radius. So in this case, we're saying, well, we don't have this full 2 pi, we just have x, we just have a certain proportion. So what would it be, right? It would just be 2 pi over 3, because now it's just a third of that triangle, of that full circle that we're doing, because we just want the arc length for that, that 1/3 of the circle, not for the full circle, not for the full 2 pi radians. We just want a third of that, 2 pi over 3 radians. Let's try B. So for B, first we need to convert this to radians. So 125 degrees times 180 degrees over pi is going to give us, let's see, 25 pi over 36. So then our arc length would be 25 pi over 36 times 45, which would be 98.13 centimeters approximately, right? So in this case, we found what proportion, right? What do we have instead of 2 pi that we're going to put for our x value to find the arc length? All right, let's do one more example. Example 4 says, determine the measure of the central angle that is formed by an arc length of 12 meters in a circle with a radius of 8. Express the answer in degree and radian measure. Okay, so let's do that. We know that the arc length is 12, and we know that the radius is 8, but we don't know the x value, right? So we know that we have a general equation, which is that a equals x times r. So in this case, 12 equals x times 8. So therefore, x is equal to 12 over 8, which is equal to 1.5, right? So the answer is 1.5 radians. Now, how can we convert that to degrees? Well, we're going to do 1.5 radians times pi radians, and then 180 degrees on top. And then we're going to get, let's see, 1.5 times 180, divide by pi, so divide by 3.141592, and that is approximately 85.9 degrees. And so therefore we have, I'm going to highlight the final answers, 1.5 radians. Oh, I don't like the way that looks. There we go. And then 85.9 degrees approximately. So there we have it. All right, well, you know what? That'll be it for today for our introduction to radians. Good work today, everyone, and I will see everyone next day. Bye, everyone.